In this lecture, we will discuss about climatology. Okay? See, Earth holds atmosphere. When Earth is surrounded from all the sides by mechanical mixture of gas, which is referred to as Earth atmosphere. Earth holds atmosphere because of the gravitational pull of the Earth. It means particularly gravitational pull of the Earth is capable to hold the gases intact around the Earth's surface. Okay? And atmosphere play very important role. It acts as a thermoregulatory instrument, right? It refers that it is the Earth atmosphere which is responsible to maintain the temperature of the Earth's surface. Okay? If there will be no atmosphere, then temperature will fall below freezing point. Okay? And the entire Earth will be snow covered. Okay? You see, as the gravitational pull of the moon is 1/6 of that of the Earth, that's why density of atmosphere in moon is very less as compared to that of the Earth. Okay? And atmosphere is also important for existence of the life, both by particularly plant and animal kingdom. Okay? We inhale gases, oxygen out of the atmosphere. Okay? So you see, as far as the question of atmosphere is concerned, the branch of geography, actually first we will discuss how atmosphere evolved, originated. Okay? So you see, actually nebula is the parent material. Nebula is the parent material constituting the entire celestial object, that is universal object. Okay? Either particularly a star, asteroid, planet, all originated out of nebula. Okay? Now see, what is nebula? So nebula is defined as mixture of gases, light mixture of gases. Okay? Light mixture of gases is referred to as nebula. There are two theories explaining nebula. First is the first concept about nebula was propounded by Kant defined nebula as the mixture of light and cold gases, and this theory is referred to as cold nebular hypothesis. Cold nebular hypothesis. It is clear now? Right? On the other hand, Laplace said nebula is hot mixture of light gases. Okay? That's why Laplace theory is referred to as hot nebular hypothesis. Getting well now? Right? Laplace concept became more popular. Now, right? That's why right now we will define nebula as the mixture of light and warm gases, hot gases. Getting well now? What is nebula became clear now? Now see, apply kinetic theory of gases. According to kinetic theory of gases, every gaseous particle remain in the state of random motion. Okay? So suppose this is one gaseous particle and this is another gaseous particle. Okay? During their movement, actually as they move, they not remain static. Their movement is zigzag type. Okay? So that's why they collide, and collision of the gaseous particle increases the temperature of certain part of nebula relatively. Okay? And this high temperature zone is referred to as protostar. Protostar. What is protostar? It is clear now? Protostar is the part of nebula which registered or recorded relatively high temperature as compared to that of the nebula now. The high temperature is due to the collision of the gaseous particle. Okay? But when the temperature of the protostar will increase above 1.5 crore degrees Celsius, then nuclear reaction will start. Okay? There are two types of nuclear reaction you see. One is nuclear fusion reaction, and second is nuclear fission reaction. In nuclear fusion reaction, a small nuclei combine to form large nuclei. Okay? And in nuclear fission reaction, large nuclei and dissociate into a small nuclei. This is nuclear fission. Okay? So you see, first at high temperature condition, nuclear fusion reaction start now. Actually, you see, you probably first understand the fact before writing. Okay? Suppose nuclear fusion start. In nuclear fusion, this is A and this is B now. A and B are reactant and C is the product now. If mass of A is M1 and mass of B is M2 and mass of product that is C is M3, then M1 plus M2 greater than M3, getting well now, or M1 plus M2 minus M3 is equal to del M. This del M is referred to mass defect, okay? And Einstein propounded the theory of relativity. He stated that actually, you see, he has stated that when mass defect occurs, this mass converts into energy as per E is equal to del mc square, where del m is the mass defect and c is the velocity of light in vacuum. Getting well? So, when temperature of protostar will increase beyond 1.5 crore degrees Celsius, then nuclear fusion reaction start, and this particularly during this process mass defect occur and large enormous amount of energy is produced. When this reaction starts, then protostar is referred to as star. It is clear? The basic difference between protostar and the star is, in protostar high temperature is due to collision of the gaseous particle, okay? Whereas in a star, high temperature is due to nuclear fusion reaction, okay? And actually in some star, nuclear fusion or fission both may occur. It is clear? Initially nuclear fusion start, and then after particularly nuclear fission start. Getting well now? Now see, very important aspect is, actually suppose this is nebula, okay, and in this nebula protostar was emitted, which later converted into a star, right? And the basic main source of energy of the star is the nuclear fusion reaction, in which hydrogen acts as a reactant and particularly helium is the product now. Getting well now? So actually suppose if this is hydrogen and this is helium, okay? Practically this is to simplify, but technically 4 hydrogen nuclei combine to form 1 helium atom in nucleus. Getting well now? So actually this reaction is initially unidimensional. This is the reactant and this is product. Getting well? Hydrogen is reactant and helium is product. Helium is further particularly form more heavy particularly material due to nuclear fusion reaction. Getting well now? So actually this reaction proceeds till reactant is present. Suppose if hydrogen is reactant and helium is the product, it means till the presence of hydrogen, this reaction will proceed and existence of the star will be maintained. Getting well? But after the entire hydrogen will convert into helium, what will happen? The entire zone will be dominated by helium particle. It is clear? Helium gases, and you know that the IP of ionization potential of helium is low. That's why helium generally remain in double ionized form. Getting well? It means this area will be dominated by ionized helium particles, helium particularly atoms, it is clear, and you know that same charge repel each other and the similar charge attract each other. It means there will be concentration of positive charge. Consequently, this star will explode. The central part will remain intact to form black hole. It is clear? And when outer peripheral region will start revolving around another star, it will produce particularly planet. It is clear? What is the process? Getting well now? Actually, again I am repeating, I am saying that nebula is the parent material constituting the entire spatial object. Nebula is defined as light and hot mixture of gases, warm mixture of gases. According to kinetic theory of gases, the gases cannot remain in the static form. They always remain in the state of random motion. During their motion, there will be collision in between the gaseous particle. The collision will increase the temperature of certain part of nebula, and this part of the nebula is referred to as protostar. When temperature of protostar will increase up to 1.5 crore degrees Celsius or more, then nuclear fusion reaction will start. Then protostar is referred to as a star. Okay, in protostar, high temperature is due to collision of the gaseous particle, whereas in a star, high temperature or energy produced in a star is due to nuclear fusion reaction. Finally, when the entire reactant will convert into product, actually in helium, so the entire area will have positively charged He++ ions there. Okay, consequently explosion will occur. the central part will remain intact, which is referred to as black hole, but the outer peripheral region will get fragmented. A star revolving around another star is referred to as planet. Okay, so you see, Earth is planet, and hence Earth is expected to produce through the same process. It means particularly you see nebula form, nebula created particularly protostar, then a star, then planet. This is the process. It is clear now? Right? Initial material was nebula, it converted to protostar, then it converted to a star, and after the explosion of a star, actually planet came into origin. Now see, nebula remained in the gaseous form, protostar remained in the gaseous form, a star also remained in the gaseous form. That's why, okay, that's why, getting well now? That's why when Earth came into origin, okay, it was also existing in the gaseous form. Getting well now? Right? So initially Earth was existing in the gaseous form. What is the process? This is as per the nuclear physics. Getting well now? Though there are several theories to propound the solar system and origin of the Earth itself now, but to simplify this aspect, we have propounded this aspect, we followed this concept. It is clear now? So actually nebula form protostar converted into a star when nuclear fusion reaction started, and after the explosion of a star, Earth, that is planet, came into origin. Okay, right now we are defining the atmosphere, that the part of actually mechanical mixture of gas surrounding the Earth is referred to as atmosphere. Getting well now? But you see, when initially the entire Earth was existing in the gaseous form, it was a major problem before the climate geographer to identify which part will be referred to as Earth and which part will be referred to as Earth atmosphere. Getting well now? So actually you see the central part of the Earth was having high concentration of gases. It is clear now? The central part was having high concentration of gases, and outer peripheral region was having low concentration of gases. It is clear now? The central part of the Earth having high concentration of gas came to be known as Earth proper. This part was referred to as Earth. Okay, and outer peripheral region having low concentration of gas came to be known as primary atmosphere. Getting well now? Actually it means at the time of origin of Earth, Earth was also having the atmosphere, and this atmosphere is referred to as primary atmosphere. Getting well now? Right? So actually primary atmosphere was the first atmosphere associated with the Earth. Okay? Now see, actually the gases constituting primary atmosphere were star-borne gases, were associated with gases, and these gases are referred to as primordial gas. Primordial gases. It is clear now? Right? The primary atmosphere was made up of primordial gases, that is a star-borne gas. Since temperature of a star is very high, that's why temperature of primordial gas is also expected to be very high now. When energy will be high, velocity will be high now, right? Actually you see, initially Earth was born along with the primary atmosphere. Getting well? And you know that atmosphere is due to the gravitational pull of the Earth. Okay? It is due to the gravitational pull of the Earth. Okay? If there will be no gravitational pull, there will be no atmosphere. The atmosphere will be lost to the outer space. It is clear now? Actually, suppose any particular object remain in the gaseous form, or any object remain in the liquid form, or any object remain in the solid form. This is gaseous state, this is liquid state, and this is solid state. Okay? If G1 is the gravitational pull associated with this gaseous system, G2 is the gravitational pull associated with this liquid system, and G3 is the gravitational pull associated with the solid system. In this case, G1 is less than G2 and G2 is less than G3, right? One can conclude that at the time of origin of Earth, Earth was having very weak gravitational pull, okay, right? Very weak, though it was having gravitational pull, but it was very weak as compared to that of present gravitational pull. Getting well now? Okay. on one hand, gravitational pull was very weak. It was not effective enough now. On the other hand, primordial gases were highly energized gases. That's why Earth could not retain the primary atmosphere for a long time, and primary atmosphere or primordial gases were gradually lost to the outer space, and Earth became atmosphereless. It is clear now, right? And I have already mentioned the fact that atmosphere act as a thermoregulatory instrument now. Okay, thermoregulatory instrument because it is capable to maintain the temperature of the Earth's surface. If there will be no temperature, then no atmosphere, then temperature will fall below 0 degree, below freezing point, you can say. Okay, so actually when Earth lost primary atmosphere, there was sharp fall in the temperature of the Earth. Consequently, Earth converted from gas to liquid state and finally into solid state. Getting well now? Solid state. It means loss of the primary atmosphere can be held responsible for attending the Earth in the solid form. Okay? What was the causative factor? It is clear now? But it is obvious how important atmosphere play important role, right? Why actually why it is referred to a thermoregulatory instrument? It is clear now? Because loss of primary atmosphere caused fall negative change in the temperature condition of the Earth. Consequently, Earth converted from gas to liquid and finally into solid form. Okay? Actually, you see, according to law of physics, when liquid convert into solid, okay, enormous volume of gases are liberated, okay, and this process is referred to as degassing process. Degassing process, okay. What is the meaning of degassing process? It is clear now? If you will go in the lab, right, and will convert liquid into gas, into solid, you will find that enormous volume of gases are being liberated now. This process is referred to as degassing process. So due to degassing process, gases were again available. On the other hand, as the Earth was changing from gas to liquid state, gravitational pull was gradually increasing. It is clear now, right? Consequently, again Earth attended another atmosphere, and this atmosphere is referred to as secondary atmosphere. Secondary atmosphere. Getting well now? Right? At the time of origin, Earth was having primary atmosphere. Due to weak gravitational pull and the highly energized primordial gases, primary atmosphere was lost to the outer space. Getting well? Right? Due to the loss of Earth's atmosphere, there occurred sharp fall in the temperature condition of the Earth. Consequently, there occurred cooling of the Earth. Okay. Consequently, Earth converted from gas to liquid and finally to solid form. During this process, as the Earth was changing its state from gas to solid state, gas to liquid, and finally into solid state, its gravitational pull was gradually increasing. On the other hand, due to degassing process, gases were available, right? That's why again Earth attended atmosphere, and this atmosphere is referred to as secondary atmosphere. Getting well now? The basic constitutional difference between primary atmosphere and secondary atmosphere was primary atmosphere was made up of primordial gases, whereas secondary atmosphere is defined as chemical mixture of gases. Getting well now? How it was different from that of primary atmosphere, it is clear now? And there is a constitutional difference between primary atmosphere and secondary atmosphere. Okay? Primary atmosphere is defined was made up of primordial gases, star-borne gases, highly energized gases, high energy gases. On the other hand, secondary atmosphere is defined as the chemical mixture of gas. What is the meaning of this? It refers that most of the elements were in the form of chemical compound. Okay, like H2S, H2O. Okay, this type of compound NH3. Okay, these were the chemical compound. So since there was a dominance of the chemical compound in the atmosphere, that's why it is broadly defined as the chemical mixture of gases. Getting well now? And again you see, during pre-Cambrian period, according to most of the geographers, during pre-Cambrian period, again Earth attended another atmosphere. No? Again Earth attended another atmosphere, and this atmosphere during pre-Cambrian period, Cambrian period, okay, Earth attained tertiary atmosphere. Tertiary atmosphere, it is clear now? Tertiary atmosphere is referred to as present day atmosphere, okay, and it is defined as mechanical mixture of gas. Mechanical mixture of gases, okay, it is clear now? What is the basic difference between primary atmosphere, secondary atmosphere and tertiary atmosphere? Getting well now? Primary atmosphere is made up of primordial gas. Secondary atmosphere was made up of chemical mixture of gases, because most of the gases were in the form of compound, okay. But present day atmosphere, which originated during Precambrian period, also known as tertiary atmosphere, is defined as mechanical mixture of gases, because most of the gases exist in the elemental form, okay, right. And this is also present day atmosphere, though after industrial revolution there occurred constitutional change, proportional change in the primary tertiary atmosphere, right. And due to this proportional or compositional change, we observed global warming type of phenomena. It is clear na? This latest atmosphere can be referred to as quaternary atmosphere, but actually you see, basically we will discuss present day atmosphere in terms of mechanical mixture of gas, okay. So how primary atmosphere came into, how particularly Earth attended the atmosphere, it is clear now. Again, you see, repeating the fact, nebula, from nebula protostar came into origin, from protostar converted into a star when nuclear fusion reaction started, right. After the destruction or explosion of the star, planet came into origin, okay, and hence Earth also originated through the same process, same mechanism, okay. When Earth originated, it was in the gaseous form. The central part of the gaseous system was having high concentration of gas. This central part was identified as Earth proper, and outer peripheral region having low concentration of gas is referred to as primary atmosphere. Primary atmosphere is defined as mechanical mixture of gas. Was made up of primordial gases, highly energized gases. Two factors were responsible for the loss of primary atmosphere. One, first was the weak gravitational pull of the Earth, as Earth was existing in the gaseous form, and second factor was primordial gases were highly energized. That's why weak gravitational pull could not hold the primary atmosphere. It was lost to the outer space. Earth became atmosphereless, which caused sharp fall. Consequently, there occurred sharp fall in the temperature condition of the Earth, and hence this decrease in temperature caused the change in the state of the Earth, right from gas to liquid and finally to solid form. Getting well now? When Earth was changing its state, right, its gravitational pull was gradually increasing, and when it converted from liquid to solid form, extensive volume of gases were liberating, and this process is referred to as degassing process, okay. Gravitational pull was relatively more effective, gases were available. That's why again Earth attended secondary atmosphere. Getting well now, okay. And secondary atmosphere is defined as chemical mixture of gases, okay. Again, during Precambrian period there occurred constitutional change, okay, in the atmospheric gases, right, because you see, according to some geographers, during this process large scale volcanic eruption occurred, which caused the cleavage of chemical bond. Consequently, chemical compounds converted into element, right, and mixture of element is referred to as mechanical mixture. Those certain chemical compounds still exist in the atmosphere, but elemental form dominate. That's why they are referred to as mechanical mixture of gases. It is clear now? So how Earth attended the atmosphere, it is clear. What is the role of atmosphere? It was also made clear now. Okay. And as far as the question of atmosphere is concerned, you see, the atmosphere extends up to the height of 10,000 kilometers. It is clear. Suppose this is Earth's surface. Atmosphere extends up to this area, right? This is the atmosphere. Getting well? This is outer space or vacuum. Getting well now? There is no atmosphere, no effective medium in this area. It is clear. This is 10,000 kilometers. 10,000 kilometer approximately. In geography, every data is approximately, not absolute, to be noted. Okay, right? And but actually, though the Earth atmosphere extends up to the height of 10,000 kilometer, the effective height of Earth atmosphere is only 10,000 kilometer, 1,000 kilometer. Getting well now, right? Effective thickness of Earth atmosphere is only up to 1,000 kilometer. Getting well, because right, this part of atmosphere directly influences the Earth's surface. It is clear na? That's why this thickness is referred to as effective atmosphere. Getting well. What is atmosphere? It is clear na? Right? Atmosphere is an important part of physical geography. As in first class I had mentioned that there are three states of matter: solid, liquid and gases. Na? The solid form is made up of rock, which is referred to as lithosphere. The study of upper crustal part of the lithosphere is referred to as geomorphology. The study of central part, interior part is referred to as geology. Again, I said that Earth is surrounded from all the sides by gases, na? Right? This gas is referred to as Earth atmosphere. Okay? And branch of geography which deals with the study of atmosphere is referred to as climatology. Getting well now? Is referred to as climatology. Now, actually, you see why the term climatology was used. This is very important, no? Right? You say why atmosphere, a branch of geography dealing with the Earth atmosphere is referred to as climatology. Why this term was used?
Because the climate of any area is of
No, you see, actually the reason is the term climatology was derived from the term clima, K-L-I-M-A, clima. It is clear now? The term clima, meaning of the term clima is angle of insolation. Angle of insolation. What is the meaning of insolation? The solar radiation which enter inside Earth atmosphere is referred to as insolation. Getting well now? Right? The term clima, what is the meaning of the term clima? The meaning of the term clima is angle of insolation. Getting well now? Actually, angle of insolation. Okay? You should know that there are three factors responsible to determine the climatic condition of any region. Okay? First factor is temperature. Temperature. Second factor is pressure. Third term is humidity. Okay? These are the three factors determining the atmospheric condition. One is temperature, second is pressure, and third is humidity. Okay? Actually, you see, temperature and humidity are referred to as active factor. Okay? And pressure is referred to as passive factor. Getting well now? Right? So, temperature, pressure and humidity collectively determine the atmospheric condition. Getting well now? Right? Because you see, important particular aspect is, if temperature is high, humidity is associated with the rainfall. No? So, if temperature is high but there will be no rainfall, then the climatic condition will be of desert type. Getting well now? If particularly you see temperature is very high and rainfall is very high, right, then equatorial type of climatic condition will prevail. It is clear now? If temperature is moderate and rainfall is also moderate, that temperate type of climatic condition will prevail now. Getting well now? Okay? If temperature is high and rainfall is very high, in this condition, or this condition is very favorable for the growth of vegetation now. For the growth of vegetation, getting well now? But if temperature is moderate and temperature is also moderate, in this condition grassland develop now. Mid-latitudinal grassland is in this particular region. It is clear now? So actually temperature, pressure and humidity are three factors determining the atmospheric condition. Okay? Which are important factors? It is clear now? Temperature, pressure and humidity are three important factors determining the atmospheric condition of any region. Okay. Now see, I said that branch of geography which deals with the atmosphere is referred to as climatology. Okay, as far as the term climatology is concerned, the term climatology was derived from the term clima, and the meaning of the term clima is angle of insolation. Okay, you see heating effect, temperature, impression of the temperature in the form of heating effect. No, so you see heating effect is directly proportional to angle of insolation. Okay, heating effect is directly proportional to angle of insolation. Suppose A is the place where angle of insolation is 30 degree, B is the place where angle of insolation is 60 degree, right, and C is the place where angle of insolation is 90 degree. Okay, as angle of insolation is directly proportional to heating effect, right, C will be the warmest zone and A will be the coldest zone. Getting well now? Okay. Actually, you see, in temperate zone, which exists between 0 to 23.5 degree north and south, angle of insolation range between 60 to 90 degree. Okay. In temperate zone, angle of insolation range between 30 to 60. Right, intermediate zone, that's why it is referred to as mesothermal zone. Getting well now? And in polar zone, the angle of insolation range between 0 to 30 only. That's why polar zone is coldest. Getting well now? So actually you see the first active factor determining the climatic condition or atmospheric condition is the temperature, and temperature depends on the angle of insolation, that is clima. Getting well now? So temperature is important factor determining the atmospheric condition. Getting well? Okay. Again you see how pressure is associated. What pressure? About pressure you see the weight of one column of air is defined at atmospheric pressure, and it is expressed in terms of millibar. The highest atmospheric pressure so far recorded was 1082 millibar. It was in particularly Siberian region. And the lowest atmospheric pressure so far recorded was 877 millibar. It was recorded in the eye of the tropical cyclone which originated in the Pacific Ocean. Getting well now? Near Philippines. Okay. Okay. These are the two extreme. Average atmospheric pressure is 1013 millibar. Getting well now? So actually pressure is second important factor. What is atmospheric pressure? What is pressure? It is clear now? Simply you feed in your mind that if there is high temperature, there will be no rainfall. Okay? If the temperature pressure, if there is low pressure, if there is high pressure, then anticyclonic condition develop and no rainfall occur. Okay? And if there is low pressure, it favor the cloud formation and precipitation may occur. You see, in equatorial zone is referred to as equatorial low pressure zone. That's why it record highest rainfall in the world. Getting well now? Right? So what is the basic difference? It is clear now. What is the impact of pressure directly? If actually rainfall occur in the low pressure zone, okay, but in high pressure zone, high pressure zone not favor the formation of cloud and hence no rainfall occur. It is clear now? Okay. So actually see, as far as the question of pressure is concerned, pressure is also important factor determining the atmospheric condition now. But you see, you go through gaseous law, okay, you know that T is inversely proportional to P, okay, right, according to gaseous law, right, there is inverse relation between temperature and pressure. It refers that if temperature is high, pressure will be low, and if temperature is low, pressure will be high now. You see, in equatorial zone temperature is high, that's why low pressure belt is formed there. But in polar zone, as pressure is high, that temperature is low, that's why high pressure is formed there. It is clear now? So actually there are two type of system. One is open system and second is closed system. In open system, in closed system, P is directly proportional to temperature. Okay? Actually in a gas filled with the particularly a cylinder filled with the gas. This is closed system now. So in this closed system, P is directly proportional to temperature now. Right? But in open system, Earth atmosphere is the example of open system now. So here particularly P is inversely proportional to temperature. Getting well now? So it, or you see actually this P is inversely proportional to temperature, and temperature depend on climate or not. Temperature depend on climate, that is angle of insolation. So again you can say that pressure depend on the angle of insolation, that is climate. Temperature depend on climate, pressure depend on climate. Getting well now? And third factor determining atmospheric condition is the humidity now. Right? As far as the question of humidity, water content of the air is referred to as humidity now. So moisture retaining capacity of the air is proportional to temperature. Okay, higher will be the temperature, more will be the moisture retaining capacity. Suppose at 1 degree Celsius, air is capable to hold 1 liter of gas. At 2 degrees Celsius temperature, 2 liter of gas. At 10 degrees Celsius temperature, 10 liter of water. Right, at 20 degrees Celsius, 20 liter of water. It is obvious that moisture retaining capacity is proportional to temperature. It is clear na? Okay, and this temperature is depending on climate, that is per angle of insolation. So you see all the three factors, namely temperature, pressure and humidity, depend on climate, that is angle of insolation, and these three factors collectively determine the atmospheric condition, that is climatic condition of any zone. That's why atmospheric condition, you can say, that's why the branch of geography which deals with the study of atmosphere is referred to as climatology. Getting well? Okay, it is clear, right? What is climatology? It is clear na? Right? Actually the branch of geography, and you see, देखिए, as far as the question of atmosphere, why the gaseous coverage of the earth is referred to as atmosphere? Because it is derived from the term atoms. ATOMS means water droplet. The entire atmospheric phenomena is the interplay of the change in the state of water. As for example, you see, when liquid convert into gas, it is referred to as evaporation. When gas will convert into liquid, it is referred to as condensation. When liquid will fall on the earth's surface, as condensation will cause the formation of cloud. Again, particularly, it will fall on the earth's surface, it is referred to as precipitation. Whatever be formed, whether it is solid, liquid, right, or the mixture of both. It is clear na? If actually the size of the water droplet is fine, it is referred to as drizzle. If it is large, it is referred to as rainfall. If precipitation occur in the form of snow, right, having low density is referred to as snowfall. If the density of ice is more, it is referred to as hailstorm. Okay, but if precipitation occur in both the form, that is liquid as well as solid, it is referred to as sleet. Okay, it is clear na? So the entire phenomena, right, is associated with the change in the state of matter, that is atoms. Atoms means water droplet na? Getting well na? The presence of water droplet in the atmosphere play very important role. Getting well na? What is climatology? It is clear. So far we discussed how earth attended the atmosphere. It is clear na? Why the branch of geography which deals with the study of atmosphere is referred to as climatology. It is clear. What is climatology? What is climate? It is angle of insolation. Getting well now? Actually, you see, it will be very obvious from this figure. Okay? Suppose this is Earth's surface. This is equator. Right? 0 degree latitude is referred to as equator. It is also referred to as great circle. Okay? It is the largest circle which is drawn on the Earth's surface. It is just imaginary line to be noted. Okay? And the line parallel to the equator are referred to as latitude. Na? Equator divide the entire earth into two equal half. The part of the earth which is located to the north of particular equator is referred to northern hemisphere, and this is southern hemisphere. It is clear na? Right? Actually, any latitudinal condition will be identified as north, and in this zone it will be identified as south. Okay? You see, 23.5 degree north, 23.5 degree north is referred to as Tropic of Cancer. Okay? and 23.5 degrees south is referred to as Tropic of Capricorn. Okay, it is clear now? And this zone is referred to as tropical zone. Okay, again you see 66.5 degree north is referred to as polar circle, and 66.5 degree south, 66.5 degree south is also referred to as polar circle. This is referred to as Arctic circle. This is referred to as Antarctic circle, close to Antarctica, close to Arctic sea. Getting well now? And this is 90 degree north, 90 degree north representing North Pole, and this is 90 degree south representing South Pole. Getting well now? This is the position of the earth. Okay. Now see, actually you see I have drawn this figure, but technically the geographical axis is inclined by 23.5. This inclination is responsible for change in the season, seasonal change. Okay, seasonal change is recorded because the polar axis is inclined by 23.5. Okay, but to simplify for clear cut and simple understanding, I have drawn this figure. Okay, you see the date on which the equator get vertical insolation is referred to equinox. Okay, that is on 21st March, sun shine vertically over the equator. Okay, getting well now? Afterward, you see March, April, May, June. On 21st June, sun shine vertically over Tropic of Cancer. This is referred to as summer solstice. Okay. Then after March, April, May, June, July, August, September. On 23rd September, again 23rd September, sun shine vertically over the equator. Okay. That since there are 2 days, that's why it is referred to as equinoxes. EQUINOXES, equal day and night. You get it well now? Right? Which is equinox? 21st March and 23rd September. On both the date, vertical insolation is received on the equator. Getting well now? And right from March to September, there is northward shifting of the sun. Okay? Then that's why northern hemisphere experiences summer season. During this period, southern hemisphere will get vertically inclined insolation. That's why winter season will prevail. Right? Since India is located here, that's why India will also experience summer season during this period now. Then after 23rd September, southward shifting of the sun occurred. So actually you see September, October, November, December. On 22nd December, sun shine vertically over Tropic of Cancer. This is referred to as winter solstice. Okay, when sun shine over Tropic of Cancer, that is 23.5, it is referred to as summer solstice, and this is referred to as winter solstice. It is clear na? 22nd December, January, February, March. It is clear. So you see, actually 23.5 degree north to 23.5 degree south. Okay, these are the 2 lines, right? The entire surface on the earth located between the 2 latitudinal lines, that is 23.5 degree north and 23.5 degree south, which will get vertical insolation at least once in a year. That is clear na? Vertical insolation means angle of insolation will be very high. Okay, if sun shine vertically here na, so here angle of insolation is 90, but at the same time angle of insolation will 60. Getting well na? So actually A is the place, if this is A na, so A is the place located between 0 to 23.5 degree north and south. Right? This is the zone where angle of insolation range between 60 to 90. Okay? But it range between 0 to 90 na? Right? So 60 to 90, right? This is recorded in A zone. Getting well now? Angle of insolation highest. That's why temperature will be high now, right? And hence this zone is referred to as tropical zone. Tropical zone or macro thermal thermal zone or energy surplus zone. Okay, right, 0 to 23 and a half degree latitude, north and south is referred to as tropical zone or macrothermal zone or energy surplus zone. Getting well now? In this is second area, second zone on the earth surface now, right? B is the area, B is the zone located between 23 and half degree to 66 and half degree north and south. Getting well now? This zone is referred to here, angle of insolation range between 30 to 60 degree. 60 degree, it is clear na? Angle of insolation is range between 30 to 60 degree na? When it is 30 to 60, 30 to 60 intermediate zone. So this area is referred to as temperate zone. Temperate zone or mesothermal zone or balance energy zone. Balance energy zone. Getting well now? Right? Clear? And C is the area located between 66 and half degree to 90 degree north and south. Here